Example 1, it says predict, so we're going to just describe all of the transformations, starting with this 1/4. Would you agree that that's a vertical compression? You would multiply y by 1/4. That's from chapter 3. Now that we're in chapter 6, we can also say that that 1/4 means that the amplitude is 1/4. Next number, the 3. That 3 is going to be a horizontal compression, x by 1/3. But now that we're in chapter 6, we can also say that our period is going to be 2 pi divided by our b value, or 2 pi divided by 3. The pi over 6 is going to be horizontal translation. Pi over 6 to the left.
Why is it 2 pi?
Why is it 2 pi divided by 3?
Yeah, for the period.
A period of a normal cosgraph or a normal sine graph is 2 pi.
Oh, it's 2 pi.
And so if you take your regular parent graph's period of 2 pi and you add the horizontal compression of 1/3, you now get 2 pi over 3. And finally, the plus 2, well, that's a vertical translation 2 up. And in this unit, that means that our sinusoidal axis is at y equals 2. Now for part B, I'm going to get you, we're going to keep it simple. We're going to put a line through the domain. Most of the time on the final exam, they say for at least one period. I'll talk about what negative 2 pi to 2 pi would look like for this graph. But for our technique works really well to graph at least one period. In fact, you would have to use our technique first, and then after that, apply it to a different domain afterwards if you wanted to draw a different domain. You're also going to find that the graph paper your textbook sometimes gives you to graph, you might want to just ignore it and graph it off to the side on your own. And then once you've graphed it off to the side, you might be able to translate it back onto their graph paper afterwards. So we're going to sketch this graph. We're going to, here I'll list our DAB-C off to the side. Okay. Once again, I'm already predicting where things are when I draw my axes. Starting with my center line at y equals 2. I'm done my d value. My amplitude is only 1/4, which is 0.25. So in my dashes here, I was thinking about that already. If my amplitude had been 100, I probably would have made my first dash like really tiny, because I would need to go up 100 and down 100. Does that make sense? But since my amplitude was only 1/4, I made my dashes bigger so that I could show, okay, down 1/4 would be to 1.75, up 1/4 would be at 2.25. My A value is now completed. DAB-C, the B, we use the B value to find our period. We've already calculated that above to be 2 pi over 3. So we choose a random spot, mark it as 2 pi over 3, and divide into 4 equal sections. Half of 2 pi over 3, pi over 3. Half of that, pi over 6. 1 pi over 6, 2 pi over 6, 3 pi over 6, which I'm going to reduce to pi over 2. B value is done. The dash. Now we're going to graph temporarily without the phase shift. It's a cosgraph. Where does a cosgraph start? At a maximum. Then the next, it'll be at the center line. Then at a minimum. Next ticking mark, center line. Back to a maximum. This is a skinny cosgraph. dash is completed. And finally, we do our phase shift, which is pi over 6 to the left. Pi over 6 is already labeled on our x-axis, so pi over 6 to the left is easy to label. And now we take each of these points and shift them over and we're done our graph for at least one period. So our graph shows one period because we're going from a maximum to a maximum. We put arrowheads on to show it continues forever. So technically we've graphed more than one period. We've graphed all of it.
The dot is just like before
The dot is just before the
the horizontal translation.
horizontal translation. And it's the reason we do it dotted is it makes it really easy to translate it left and right if you can see what it was before. If you try to do it all at once, chances are you'll make a mistake somewhere. Looks like I had some issues with the last point. Looks like it went up a little bit. That's just carelessness. Oh. Okay. Now, the question that they asked was to graph it from negative 2 pi to 2 pi. Can you see that 2 pi over 3 here is only a third of 2 pi? You would have to mark another same distance here. That would be 4 pi over 3. And another same distance, which would go off my screen, to be 2 pi. And then you'd have to go maximum, centerline, minimum, centerline, maximum, centerline, minimum, centerline, maximum, centerline, minimum, centerline. And then you'd also have to go back to negative 2 pi, which would go all the way out to here. And it would just be lots of dots and lots of drawings. So it's a little bit annoying. But even if you had to do that, I would still recommend drawing this first and then going, okay, underneath it, now I'm going to draw it for 2 pi. So if I had to draw it underneath, okay, draw my axes very similarly, but now I'm going to mark 2 pi, and then I'm going to think, okay, a third of that, that's my 2 pi over 3, and then this is divided into 4 sections, this one's divided into 4 sections, this one's divided. Oh, and I didn't give myself enough room to go to negative 2 pi. And you would have like, right here's one of them, and then another one. Oh.
Why didn't we graph it to like
We didn't graph it to the domain it said because most likely on your exam they're going to ask you for at least one period. Okay? It's graphing it from the domain that they said is tedious because you're just doing the same thing over and over again. And so this will help you understand it better. That's why I changed that. Yes, and then yes. Yeah. Like, do you have to show that dotted line? No. But if you make a mistake in one of your points, just chances of making a mistake increase. Okay? Sometimes your shift is not easy. Like all of the shifts that we had happen to be nicely on the points that we have. But I could do this, here in purple. Just for fun, everything was the same. Cos 3 x plus pi over 4 plus 2. Okay? Now my shift is pi over 4. Where's pi over 4 on here? Well, I'd have to take pi over 2 and divide it into 4 equal sections. Or I think this is 30 degrees, so this is pi over 4. So now my shift would be over to here. And I have to think about where that would be in relation, that same distance from all my points. Then it'll be easier if you have that dotted line to begin with. Right? What would happen in this one if instead of pi over 4 it said, oh, let's shift it 1 to the left. Where's 1 on here? Oh, no, pi is 3.14. Don't tell me pi is equal to 1. Where would 1 be? Maybe right there? 3.14 divided by 3 is just a little bit more than 1. Does it make sense that 1 would be there? This is 1.57. Oh, so you could have values that don't match up as nicely. Then that dotted line makes it really helpful. Okay, try some for practice. Questions 3, 8, 9, 10, and 11. And careful, I think 11 isn't in factored form.